Solve the equation for the specified variable. Here we're given the equation w equals x plus y plus z all over 3. And we're being asked to solve for x. So let's get out our highlighter and let's highlight the x to remind ourselves that that's what it is that we want to be solving for. So we're going to work to get x all by itself, which means the y and the z and the 3 somehow all need to get over to the other side of the equation so we can leave the x by itself. So let's see how we're going to start here. This is an equation that has a fraction thing going on in it, and we know that it's always a good idea to get rid of fractions. So let's go ahead. When we're solving this equation, we want to clear the denominator. So we're going to multiply both sides by 3. So we're going to multiply on this side by 3, and we're going to multiply on this side by 3. So on the left side of the equation, we have 3w. But on the right side of the equation, the 3 here and the 3 here have canceled out because remember that 3 that we multiplied by is like 3 over 1. The 3 in the numerator and the 3 in the denominator cancel out. Because this 3 is canceled, there's nothing left to distribute through. We're just left with x plus y plus z. So we managed to get rid of the 3 from the right-hand side, but we still have a ways to go to get that x alone. So let's just highlight that x again, just to remind ourselves that that's what we're looking for. That's what we're trying to get by itself. So the y and the z, we can see, are both being attached to the x by addition. They're at that same level in my order of operations. If we think of our order of operations over here, so parentheses on top and then exponents, then multiplying or dividing, and then adding or subtracting. Both the y and the z are connected at this weakest connection in my order of operations. So that means that since they're both connected at that level, I can get rid of both of them at the same time. We can subtract y and we can subtract z. And if we're going to subtract y and subtract z from the right side, we need to do the same thing on the left side. We're going to subtract y and we're going to subtract z. So let's see how this all shakes out. On the right side, the y's are going to cancel and the z's are going to cancel. They're all going to cancel at the same time. And that leaves the x all by itself. Now the left side, it looks like a bit of a mess. I've got this 3w minus y minus z. Notice that none of those are like terms. None of those are going to combine with each other. So the best we can do to write our final answer is to say 3w minus y minus z. It looks really funny to have this be our final answer, but remember, we're solving a formula that has more than one variable in it for one of its variables. And so if we're solving a formula for one of its variables, our answer is also going to look like a formula. Things aren't going to tidy up very well, but that would be our final answer.